Multiply both numerator and denominator by 1 minus cos A, that is rationalizing the denominator. 1 minus cos A divided by 1 minus cos A. 1 into minus 1 is minus 1, plus cos into cos is cos square A, minus into plus it is minus cos A, whole divided by, in the denominator we have cos A. A square minus b square is a plus b into a minus b. So this can be written as cos square A plus sin square A into cos square A minus sin square A. Hello dear students, welcome to this session of Basic Mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important problems in angles and trigonometric ratios. So in trigonometric ratios we have studied few problems for 1 and 2 marks. Now let us discuss 3 marker and 5 marker questions in this session. Now very important concept I am going to discuss today. Now let us come to straight away a first problem. This is a 3-mark question. Prove that 1 minus cos A divided by sin A is equal to sin A divided by 1 plus cos A. So you can take LHS and simplify RHS. Otherwise you can take RHS and simplify. You will get the LHS. So let us take LHS first. What is LHS? LHS is 1 minus cos A divided by sin A. Now, 1 minus cos A divided by sin A. Let us rationalize the numerator. For just multiply and divide by 1 minus cos A divided by sin A, multiply and divide by 1 plus cos A. 1 plus cos A divided by 1 plus cos A. Rationalizing the numerator, multiply and divide by 1 plus cos A. Then what you will get? 1 into 1 is 1, minus cos into cos is cos square A, 1 minus cos square A divided by, in the denominator, sin A into 1 plus cos A as it is. It won't change us. Now 1 minus cos square. 1 minus cos square, you know what is the formula for 1 minus cos square? 1 minus cos square is equal to sin square A divided by sin A into 1 plus cos A. Now here sin and sin gets cancelled. What is remaining in the numerator is sin A divided by 1 plus cos A, which is the required RHS. See, sin A divided by 1 plus cos A. Just take LHS, rationalize the numerator, you will get the answer. So if you want, you can consider the RHS. Second method, R over R. Let us take RHS. What is RHS? RHS is sin A divided by 1 plus cos A. Now just rationalize the denominator. So multiply both numerator and denominator. Sin A divided by 1 plus cos A. Multiply both numerator and denominator by 1 minus cos A. That is rationalizing the denominator. 1 minus cos A divided by 1 minus cos A. Now this is multiply it in the numerator, sin A into 1 minus cos A divided by 1 into 1 is 1, plus into minus minus, cos into cos is cos square A. This is sin A divided by 1 minus cos A in the numerator as it is, divided by, what is 1 minus cos square? 1 minus cos square is sin square A. Now one sin A and sin A gets cancelled. What is left in the numerator is 1 minus cos A divided by, in the denominator, sin A. That is what the LHS is. So that is a LHS. See, 1 minus cos A divided by sin A. So any method you can follow for this. Hope you followed. Either take LHS and simplify, you will get RHS, or you can take RHS and simplify, you will get the LHS. Very easiest problem. Now move on to the next problem. What is the next problem? Prove that 1 plus cosecant A into 1 plus cos A into 1 minus cosecant A into 1 minus secant A is equal to cos A. Now let us take LHS for this. LHS 1 plus cosecant A into 1 plus cos A into 1 minus cosecant A into 1 minus secant A. Now let us group these two. 1 plus cosecant A into 1 minus cosecant A, one group. 1 plus cosecant A into 1 minus cosecant A. And what is remaining is 1 plus cos A into 1 minus secant A, another group. Now, so this can be written as, simplify this, 1 into 1 is 1, minus cosecant into cosecant is cosecant square A, 1 minus cosecant square A into 1 plus this cos A as it is into 1 minus secant can be written as 1 by cos. Now, there is one formula, you know this identity, 1 plus cot square theta is equal to cosecant square theta. 1 plus cot square is equal to cosecant square theta. So, if you interchange this, 1 minus cosecant square theta is equal to minus cot square theta. If you interchange, 1 minus cosecant square is equal to minus cot square theta. So, this can be written as minus cot square A into, this is as it is, 1 plus cos A into, take LCM, cos A is the LCM, multiply 1 into cos A is cos A minus 1, cos A minus 1. So, this can be written as minus cot square A into, multiply the numerator. If you multiply the numerator, so what we will get, 1 into cos A is cos A, again 1 into minus 1 is minus 1, plus cos into cos is cos square A, minus into plus it is minus cos A whole divided by, in the denominator we have cos A, right. Now, this can also be written as, here plus cos A and minus cos A gets cancelled. I will go to the next page. So, that is equal to minus cot square A into, what we have is cos square A minus 1, cos square A minus 1 divided by, in the denominator we have cos A, right. Since you know one more formula, sin square theta plus cos square theta is also equal to 1. So, cos square theta minus 1. So, here cos square minus 1, if we transfer this, sin square theta is equal to 1 minus cos square theta, sin square theta is equal to 1 minus cos square theta. What is cos square theta minus 1? Cos square theta minus 1 can be written as minus sin square theta. Now, that is equal to minus cot square A into, cos square A minus 1 is minus sin square A divided by cos A. Now, this minus and minus becomes plus, cot theta can be written as cos square A divided by sin square A into this sin square A whole divided by this cos A. Now, what happens when sin square and sin square gets cancelled? We have cos square A divided by cos A in the denominator. When cos and cos gets cancelled, that is equal to cos A, which is the required RHS. What is RHS? Cos A. That is it. This is how we are going to solve this. Let me explain once again. See here, let us group the terms containing 1 plus cosecant A and 1 minus cosecant A, these two as one group. Then remaining 1 plus cos A into 1 minus sec A another group. So, 1 into 1 is 1, plus into minus minus, cosecant A into cosecant A is cosecant square A, 1 plus cos A as it is, 1 minus secant A can be written as 1 by cos A. Now, here 1 minus cosecant square is nothing but minus cot square A. Just take LCM, that is cos A is LCM, 1 into cos A is cos A minus 1, multiply. So, you will get minus 1 plus cos square A divided by cos A into minus cot square A, that can be written as minus cot square A into cos square A minus 1 divided by cos A. Since what is sin square? 1 minus cos square is sin square. So, cos square theta minus 1 is also equal to minus sin square. So, this becomes minus sin square, minus into minus plus, cot is nothing but cos by sin. One sin square gets cancelled. What we have in the numerator, cos square A, in the denominator cos A, one cos and cos gets cancelled. That is equal to cos square A by cos A is equal to cos A, which is the required RHS. Hope you followed. This is a 5-marker question. Now, let us come to the next problem. To prove that 1 plus cot A minus cosecant A into 1 plus tan A plus secant A is equal to 2. What is the answer? This is 2. Now, let us take LHS. What is LHS? LHS 1 plus cot A minus cosecant A into 1 plus tan A plus secant A it is, plus secant A. Now, use quotient relation as well as the reciprocal relation. So, this can be written as 1 plus cot A can be written as cos A by sin A minus cosecant A is 1 by sin A. The reciprocal relation for cosecant is 1 by sin. Similarly, 1 plus tan can be written as sin A divided by cos A, and plus secant A is equal to 1 by cos A. Right. Now, take LCM. Here sin A is the LCM. Multiply it. 1 into sin A is sin A, plus sin and sin gets cancelled. Cos A, sin gets cancelled, minus 1. Here cos A is the LCM. Take LCM. Cos A is the LCM. 1 into cos A is cos A, plus cos and cos gets cancelled. In the numerator you have sin A into 1 is sin A, cos and gets cancelled, plus 1. Now if you observe carefully, this can be written as sin A plus cos A minus 1 divided by sin A into the denominator is same as it is sin A plus cos A. Let us interchange this sin A plus cos A plus 1. Sin A plus cos A, sin A plus cos A plus 1. Now let us simplify. If you observe carefully, the numerator is of the form A plus B into A minus B. A, this is A minus B into A plus B. So let me write, this can be written as, this is equal to A plus B into A minus B is A square minus B square. So A square sin A plus cos A whole square minus B square, 1 square is 1. Now in the numerator, if you observe carefully, this is of the form A minus B into A plus B. A minus B into A plus B is nothing but A square minus B square. This is A and B. A minus B, A plus B. So sin A plus cos A is A. So this is equal to sin A plus cos A whole square minus 1 into 1 is 1 square is 1 divided by the denominator is same sin A into cos A. That's it. If you simplify, you will get the answer. Now apply A plus B whole square formula. A square sin square A square plus B square cos square A plus 2AB 2 sin A cos A minus 1 divided by sin A into cos A. Now what is sin square plus cos square? Sin square plus cos square is 1 plus 2 sin A into cos A minus 1 divided by sin A into cos A. Now cancel, minus 1 and plus 1 gets cancelled. What is left in the numerator is 2 sin A cos A divided by, in the denominator we have sin A into cos A. Sin A cos A gets cancelled, that's equal to 2 into 1, that's equal to 2, which is the required RHS. That's it. Very simple problem, and 5 marks is very important. See, just use the quotient relations and the reciprocal relation. If you observe carefully, this is of the form A minus B into A plus B is A square minus B square. That is nothing but sin A plus cos A whole the square minus 1 square is 1. A square plus B square plus 2AB sin square plus cos square is 1, plus 1 minus 1 gets cancelled. 2 sin A cos A, in the denominator sin A cos A and numerator gets cancelled. 2 into 1 is 2, which is the required RHS. That's it. Hope you followed. This is very important for 5 marks. Now move on to the next problem. Prove that cos to the power of 4A minus sin to the power of 4A is equal to 1 minus 2 sin square A. Now here let us take LHS. What is LHS? Cos to the power of 4A minus sin to the power of 4A. Now this can be written as cos square A whole square minus sin square A whole square. So this is of the form A square minus B square. A square minus B square is A plus B into A minus B. So this can be written as cos square A plus sin square A into cos square A minus sin square A. Now what is cos square theta plus sin square theta is 1 into cos square can also be written as 1 minus sin square A minus sin square A. This is 1 into 1 is 1 minus sin square is minus 2 sin square A, which is the required RHS. That's it. Very simple problem. See, cos to the power of 4 minus sin to the power of 4 can be written as cos square A minus sin square A, cos square A whole square, sin square A whole square. This is of the form A square minus B square. A square minus B square is A plus B into A minus B. So cos square A plus sin square A into cos square A minus A. If you multiply cos square into cos square, cos to the power of 4 plus into minus minus, sin square into sin square is sin to the power of 4. Cos square theta plus sin square theta is 1 minus 1 into 1 minus cos square A is 1 minus sin square A minus sin square as it is. 1 minus sin square is 2 sin square. 1 minus 2 sin square A, which is a required answer. Now let us come to the last problem. There is one important problem. Prove that, the problem is like this. Prove that cos theta by 1 minus tan theta, cos theta divided by 1 minus tan theta plus sin theta divided by 1 minus cot theta is equal to, this is equal to cos theta plus sin theta. This is very important problem. So prove that cos theta divided by 1 minus tan theta plus sin theta divided by 1 minus cot theta is equal to cos theta plus sin theta. Now let us take LHS. What is LHS? Cos theta divided by 1 minus tan theta plus sin theta divided by 1 minus cot theta. Now this can be written as cos theta as it is. In the numerator, cos theta divided by 1 minus tan theta can be written as sin theta by cos theta plus in the numerator here sin theta divided by 1 minus in the denominator cot theta can be written as cos theta by sin theta. Take LCM. Numerator is same. Cos theta divided by cos theta is the LCM. Cos into 1 is cos theta minus sin theta plus in the numerator sin theta as it is. In the denominator take sin theta as the LCM. 1 into sin theta is sin theta minus cos theta. So this goes to the numerator. Cos into cos is cos square theta divided by, in the denominator we have cos theta minus sin theta plus sin into sin is sin square theta divided by, in the denominator we have sin theta minus cos theta. Now this can be written as, here this is same cos square theta divided by cos theta minus sin theta. Let us convert sin theta minus cos theta. This can also be written as sin theta minus cos theta. You can be written as minus cos theta plus sin theta. You can take a minus out. This becomes cos theta minus sin theta. So therefore this minus into plus becomes minus this sin square theta divided by, in the denominator we will have cos theta minus sin theta. Now you can take cos theta minus sin theta as the LCM. So here cos theta minus sin theta is the LCM. These two gets cancelled. Cos square theta minus sin square theta. Now what is cos square minus sin square? A square minus b square. That is nothing but cos theta plus sin theta into cos theta minus sin theta. So divided by, in the denominator we have cos theta minus sin theta. These two gets cancelled. You will get cos theta plus sin theta as the RHS. So therefore the required answer is cos theta plus sin theta, which is a required RHS. That's it. So this is how we are going to solve this problem. Hope you followed. So these are few problems based on trigonometrical ratios and the identities. So that's all regarding today's session. Let us meet with the different concept in the next session. Thank you very much.